Okay, good morning and welcome to a different version of our flipped classroom. So today I'm just going to go over the summary activity that you were assigned for your asynchronous day. I'll post the times for each type of problem starting so that you guys can just come back and check your work. So we'll just begin here. These problems are asking us to predict whether, hang on, I don't know why I'm not focused there for a second. There we go. Whether this is going to make a solid. So the easiest way to do that is just to go ahead and do the double displacement reaction. So we have barium nitrate, which is aqueous, reacting with sodium chloride, which is also aqueous. And we know that this is a double displacement reaction because we have two ionic compounds. So we're going to take the anion from the barium nitrate and put it with the cation from the sodium chloride, and vice versa, anion from sodium chloride with cation from barium nitrate. So the cation is barium, the anion is chloride. We know that barium is a +2 ion and chloride is a -2 ion. So I'm going to go ahead and put a 2 here so that I have 2 -1s to go with my +2. And then my other compound is going to be sodium with nitrate. And we know that sodium is a +1, nitrate is a -1, and so I don't need any additional subscripts. So I'm going to go ahead and balance my equation. I have 2 chlorines here and only 1 here. So I'm going to put a coefficient of 2 in front of sodium chloride. And then having put the 2 here, that gives me 2 sodiums. So I'm going to come over here and put a 2 in front of sodium nitrate. That gives me 2 sodiums and 2 nitrates. And we can see that I have 2 nitrates on this side. So we're good to go. Now, we have to decide whether a solid will form. So I'm going to look down through my list of solubility rules, and I'm going to see that there's not a rule about barium, but the 4th rule says that chloride salts are soluble. And so I know this is going to be soluble. And then when I look at sodium nitrate, rule number 1 says any salt containing sodium is always soluble. So this is also going to be aqueous. So no solid forms. So I would actually write for this one, no reaction. So for our second problem, we have sodium sulfide and copper 2 nitrate. So Na2S plus CuNO3 2. These are both aqueous. And again, we're just going to have our anions switch places. So I'm going to have sodium and nitrate. And again, sodium is a +1, nitrate's a -1. I don't need any additional subscripts. Plus copper, which is Cu, sulfide. Now, because this copper is with 2 nitrates, I know that this copper has a +2 charge. Sulfide has a -2 charge. +2, -2, don't need any additional subscripts. I'm going to come back and balance my equation. I have 2 sodiums on the left, so I'm going to put a 2 in front of the sodium nitrate. That gives me 2 nitrates here, 1 copper, 1 sulfur, 1 sulfur. Now we determine whether any of them are going to produce a solid. So sodium nitrate, we have sodium. We know anything containing sodium is always soluble. So we're going to give that an AQ. But then we hit copper 2 sulfide, and we know anything containing a sulfide, this is rule 7, is insoluble. And so we're going to give this a little S for solid. So identify the solid. The solid is copper 2 sulfide. And write the balanced equation, which we've already done. All right, last one like this. We have ammonium chloride reacting with lead 2 nitrate. And we know it's lead 2 because there are 2 nitrates with the lead, which tells us that the lead, it has a charge of +2. So I put the ammonium with the nitrate. And again, checking, ammonium is a +1, nitrate is a -1. I don't need any additional subscripts. Plus lead 2 chloride. Since we know that lead is a +2 and chloride is a -1, we need 2 chlorides to go with our 1 lead. And so we're going to come back to this side, put a 2 in front of ammonium chloride so that I have 2 chlorides, 2 ammonium. So we're going to put a 2 in front of ammonium nitrate. And that gives me the 2 nitrates to go with my 2 nitrates, 1 lead, 1 lead. And now our equation is balanced. Now we have to look and see if any of these are solids. So first one we look at is ammonium nitrate. Rule number 1 says anything containing ammonium is going to be soluble. So we're going to give that an AQ. And then rule number 3 tells us anything containing lead is going to be insoluble. So we're going to give that a little S. Now, you might notice that here, this lead compound says that it's aqueous. That's because the rule for nitrate comes before the rule for lead. And so because this is with nitrate, it's soluble. Once it's with chloride, it's insoluble. So again, the solid is the lead 2 chloride. And we've written our balanced chemical equation. So number 2 asks us to just write and balance equations. So we're going to take our aqueous sodium chloride. Sodium is Na, chloride is Cl, +1, -1, and it tells us it's aqueous. Is added to, so I'm going to write a plus, aqueous silver nitrate. Silver is Ag, nitrate is NO3. We know that silver is +1, nitrate's -1. Don't need any additional subscripts. It tells us aqueous, so I'm going to give a little AQ. To form, so I put an arrow, solid silver chloride, so AgCl, and that's going to have a solid. Silver's +1, chloride's -1, no additional subscripts, plus aqueous sodium nitrate. +1, -1, no additional subscripts, aqueous, AQ. These are pretty easy at this point. So aqueous sodium sulfide, NaS. Now we know sodium's a +1, sulfide's a -2. So I need 2 sodiums to go with my sulfide. Tells me this is aqueous. Is mixed with aqueous copper 2 nitrate, so Cu and then NO3 for nitrate. But it's copper 2, so we know this has a charge of +2. Nitrate is -1. So I need 2 -1s to go with my +2. This is also aqueous. To form, so here's our arrow, solid copper 2 sulfide, so CuS. This is a +2, this is a -2. I don't need any additional subscripts, but it's solid, so we put a little S. And aqueous sodium nitrate, so NaNO3. Notice I did not bring over this 2 or this 2. I'm looking at charges. Sodium's a +1, nitrate's a -1. Don't need any subscripts to make this compound neutral. But I do have 2 nitrates and 2 sodiums, so I'm going to put a coefficient so that my equation is balanced. Remember, subscripts are only put in if we need them to make the compound neutral. Coefficients are used for balancing. Okay, last one like this, aqueous ammonium chloride. Ammonium is NH4, chloride is Cl, and it tells us it's aqueous. Ammonium's a +1, chloride's a -1, so don't need any additional subscripts. Is mixed with aqueous lead 2 nitrate, so PbNO3. We know lead's a +2, nitrate's a -1, so we're going to have 2 nitrates to go with our lead. This is also aqueous. To form, okay, solid lead 2 chloride, so PbCl. Lead's a +2, chloride's a -1. So I need 2 chlorides to go with my 1 lead. And it tells me this is solid. And aqueous ammonium nitrate. So ammonium is NH4, Nitrate is NO3. This is a +1, this is a -1. I don't need any additional subscripts. But I can see that I have 2 nitrates on the reactant side, so I'm going to put a 2 coefficient in front to give me 2 nitrates on the product side. That will give me 2 ammonium, so I'm going to come and put a 2 in front of ammonium chloride. That gives me 2 chlorides to go with my 2 chlorides, 1 lead, and my equation is balanced. Okay, so these were a little challenging because you had to use solubility rules. These are just a matter of writing and balancing. Now we move on to acid-base reactions. So we're going to write balanced chemical equations for the reactions of the following acids and bases. And this is our reminder that when we react an acid and a base, we should always get water and a salt. So hydrochloric acid is HCl. That hydro in front tells me that it's just hydrogen and the element. And this is an acid, so we're going to give this a little AQ. And potassium hydroxide. So potassium is K, hydroxide is OH, potassium's a +1, hydroxide's a -1. Don't need any additional subscripts. Potassium salts are always soluble. So we now have our reactants, and we know that our products are going to be water and some salt. So we're going to take the cation from the base and the anion from the acid and put them together. Potassium and chloride, and potassium's a +1, chloride's a -1. I don't need any additional subscripts. Anything with potassium is soluble, so this gets an AQ. So I have my water, and in this case, my salt is potassium chloride, and everything is balanced. Rubidium hydroxide. So we're going to pull out our periodic table, and we're going to find that rubidium is RB, and we're going to try to remember whether that's in group 1 or group 2. Actually got the teacher there on this one. So rubidium is in group 1, so it's a +1. Hydroxide is a -1, so RbOH. And nitric acid, so HNO3. Because this is just an ic acid and not a hydroic acid, I know I'm looking for hydrogen and the 8 ion, so I'm looking for the nitrate ion. So nitrate and hydrogen. Nitrate is a -1, hydrogen is a +1. Don't need any additional subscripts. So AQ, rubidium is group 1, so it's soluble, AQ. And we know that we're going to have water and a salt. So we're going to take the rubidium and put it with the nitrate, RbNO3. And because this is a group 1 and this is nitrate, this is a soluble salt. 2 hydrogens, 1 oxygen, 1 oxygen, 1 nitrate, 1 nitrate, 1 rubidium, and it's balanced. So now C, perchloric acid tells me that I have hydrogen, and the perchlorate ion, perchlorate is ClO4. That's a -1 charge. This is a +1 charge, no additional subscripts. This is aqueous because it contains hydrogen, and that's a group 1. And sodium hydroxide, also aqueous because it contains sodium, group 1. Same process, we know it's going to make water. And we're going to take the cation and the anion and put them together. So we have NaClO4, sodium's a +1, perchlorate is a -1. So this does not need any additional subscripts, contains sodium, so it's soluble. Okay, hydrobromic acid and calcium hydroxide, our last neutralization reaction. So again, we have this hydroic acid, so we know it's hydrogen, and the element, which in this case is bromine. Bromine's a -1, hydrogen's a +1, so no additional subscripts. This contains hydrogen, so it's soluble. Calcium hydroxide, CaOH, but we know calcium's a +2, hydroxide's a -1, so we're going to have 2 hydroxides to go with our calcium. And then most hydroxides are insoluble, but this is with calcium, which is one of the heavy group 2s, so this is soluble. So we're going to give this an AQ. Now, we're still going to make water, H2O. And I know that there's some extra hydrogens hanging out. We're going to take care of those in a minute. And calcium bromide. So calcium is a +2, bromide is a -1. So I need 2 bromides to go with my calcium. Water is liquid. Calcium bromide, because it contains bromide, is soluble. So this is AQ. Now I have 2 bromide ions, so I'm going to put a 2 in front of my hydrobromic acid. That gives me 2 hydrogens and 2 hydrogens, which means I need 4 hydrogens. So I'm going to put a 2 in front of the water, and that'll give me 2 oxygens, 4 hydrogens, 4 hydrogens, and my equation is balanced. Okay, so synthesis reactions mean that 2 things are coming together to make 1. So when we combine sodium and oxygen, we're going to get sodium oxide. So NaO. But now we need to think about charges. Sodium is a +1, oxygen is a -2. So I need 2 sodiums to go with my oxygen. This is an oxide, so this is going to be solid. So an ionic salt. I have 2 sodiums, so I need to put a 2 in front of sodium, but I have 2 oxygens on this side, and I have only 1 over here. So I'm going to go ahead and put a 2 in front of Na2O to give me 2 oxygens on the product side to match my 2 oxygens on the reactant side. Now I need 4 sodiums, so I'm going to put a 4 in front of the Na. Now it would have been okay if I'd put a 2 here, but then I would have come back and put a 2 here, and I would have had to change that 2 to a 4. So either way works. All right, now we're going to put calcium together with nitrogen. Again, synthesis reaction. We know we're going to make 1 compound. So that's going to be CaN. But we know calcium is a +2 and nitrogen is a -3. So I need 3 calciums to go with 2 nitrogen, so that I have 3 times +2 and 2 times -3. So I have a +6 and a -6. Or we can think of this as just the crisscross rule. So now I need to balance this. So I already have 2 nitrogens on each side, so I just need to fix calcium. So I'm going to put a 3 in front of calcium on the reactant side. This is another ionic compound, so this is going to be a solid. Now we have decomposition reactions. That means that this single compound is going to break apart into its component elements. So H2S, or hydrogen sulfide gas, or hydrosulfuric acid, is going to break apart into hydrogen. Now you remember that hydrogen is one of the 8 elements that is never alone. It's one of the diatomics, so we're going to give that an H2, and sulfur. Hydrogen is a gas. Sulfur as an element is a solid. 2 hydrogens, 1 sulfur, and we're done. Sodium chloride is going to break apart into sodium and chlorine, but chlorine, like hydrogen, is one of our diatomic elements, so this is going to have a 2 here because chlorine's never by itself. We know chlorine is a gas. We know sodium is a solid. We have 2 chlorines, so I'm going to come back over here and put a 2 in front of the NaCl, and that's going to require me to put a 2 in front of the sodium as well. Okay, last set. These are our single replacement reactions. So this is that the element by itself is going to come in and replace an element in the compound. And remember, like replaces like. So here, bromine, if it's going to do anything, is going to replace chlorine, not sodium, because it's a nonmetal, it's going to replace a nonmetal. But we also need to use the activity series to think about whether or not bromine is capable of kicking chlorine out, or whether chlorine is going to hold on to sodium too strongly. And in this case, because bromine is lower on the activity series than chlorine, it's not going to be able to replace the chlorine. So there will be no reaction here. Now, when it comes to copper and aluminum chloride, we are going to refer back to that activity series. We know that if copper is going to replace anything, it's going to replace aluminum, because metals replace metals and nonmetals replace nonmetals. So is copper higher on the activity series than aluminum? Yes, it is. So the copper is going to come in and kick the aluminum out and leave the aluminum alone. And so we're going to have copper, and it's going to be with the chlorine. Now we're going to assume that this copper is going to take a +2 charge. So we're going to call this copper 2 chloride. That's the more common form of copper. This would then be soluble. So we're going to put an AQ, and the aluminum is going to be by itself. And that's going to be a solid. I have 3 chlorines here and 2 here. So I'm going to need to put a 3 in front of chlorine, copper 2 chloride, and a 2 in front of aluminum chloride. And then that's going to require me to put a 2 in front of aluminum and a 3 in front of copper in order to make it so that I have 6 chlorine, 3 copper, 2 aluminum, 2 aluminum. So we'll go through the same process here. We have silver nitrate and solid platinum, and we're going to look at our activity series, and we're going to see if platinum is higher than silver on the activity series. And when we look at our activity series, we find that platinum is lower than silver, and so platinum is not going to be able to kick silver out of this reaction. And so we're going to say no reaction. And now our last one, we have calcium iodide and bromine. So again, bromine, being a nonmetal, is going to replace iodine if it can. Not the calcium, but the iodine. So we look at our activity series and we see that bromine is higher than iodine. So calcium, bromide. Calcium is a +2, bromine is a -1. So I need 2 bromine to go with my calcium. And that's going to be dissolved in our solution. And now the iodide is going to be by itself, but iodide, being a halogen, is never alone. It's one of our diatomic elements. So we're going to write this as I2, and then iodine as an element is a solid. And that's our summary. As always, if you have any questions, let me know. I look forward to seeing you in class.